Now that we know what radians are, it might make sense to be able to convert from degrees to radians. I'm going to caution you though, you want to be comfortable in both because sometimes degrees are better, sometimes radians are better, and you don't want to get in the habit of converting all the time. So let's go ahead and take a look at how they compare to each other. So in the occasions where we do need to convert radians to degrees, we're going to need a conversion factor. So let's pick a value where we know the radians and degrees are the same. So in both these cases, we know that 180 degrees and pi describe the same angle. Well, that means they're the same, and if you divide anything by itself, it's just equal to 1. And that's kind of the concept behind a conversion factor. And that is that you can always multiply by 1 without changing the value of something. So let's say that we had 185 degrees and we wanted to turn that into radians. Well, a conversion factor has to be equal to 1, and then we kind of have to decide what do we want to cancel and what do we want. We want to put the value or the type of thing that we want on top and the type of thing that we kind of want to eliminate on the bottom. So in this case, we want radians. So we'll put our radian measure or pi on the top, and then we'll put the equivalent number of degrees on the bottom. And what's effectively happening here is the degrees are going away. They're going to kind of cancel each other out. And since we're multiplying by 1, we know that whatever this equals, it's still going to have the same value. We just changed the units. And now we have written this in radians. One note that I'm going to make here is radians is not a unit, it's a length. So we could have additional units here. Examples would be inches, feet, miles, meters. Anything that describes lengths could be the units in radians. In this particular case, we didn't really write them, so it would just be kind of a generic unit. Let's see if we can go the other way now. So let's say we have something that's written in radians, and we know it's radians because we don't see a degree mark anywhere, and it's describing an angle. And let's convert it into degrees. So once again, I need a conversion factor, and that conversion factor is going to be equal to 1. So as long as I put the same thing on the top and bottom, I'm going to be good. The thing that I want is degrees, so I'm going to put that on the top. And the thing that I want to eliminate is radians. And so I know this is equal to 1. I can just multiply this out and I won't change the value, but I'll be getting the degrees unit that I want. And we see that 2 pi over 3 radians, or just 2 pi over 3, that arc length, is going to be 120 degrees. I want you to keep in mind, radians don't have to have pi in them. So let's look at one more example before we move on. So let's say we have an angle in radians of 2 over 3. It's a length. We're all good. And we know that it's radians because there's no degree symbol, which means it's a length, which is what radians is. And let's multiply it by our conversion factor. So we want degrees, so we'll go ahead and put that on top. And we want to kind of eliminate those radians, but really we just want to make sure that this thing here, this fraction, is equal to 1. And I have those units, the degree units that I want. 120 degrees over pi, it's going to be a little less than 40 degrees. Degrees are a unit. 360 degrees is 1 full revolution around a circle. Radians, however, are a length. It is the 2 pi is the circumference of a circle. So don't think of the pi as a unit. The only reason that we usually see a pi in radians is because the circumference of a circle with a radius of 1 is 2 pi. It's an important distinction, something to keep in mind as you move forward.